What started as radical experiments in radar invisibility became the deadliest force in modern warfare. Today, we trace the complete evolution of stealth aircraft from the very first flying wings to today's fifth-generation hunters. This is the story of stealth. Starting off with World War II and early experiments, the Northrop N-1M. This tiny experimental flying wing from 1940 was basically a motorized kite with a pilot stuffed inside. It proved that aircraft without tails could actually fly, setting the stage for future stealth designs. Up next, the Northrop N-9M. A scaled-down testbed built to refine the flying wing concept. With smooth aerodynamic surfaces and no vertical stabilizers, it accidentally reduced radar reflection while engineers were simply chasing better flight characteristics. Then the Northrop YB-35. This massive piston-powered flying wing bomber was designed to strike Europe from America. Its radical shape confused radar operators, though that wasn't the original intent. Mechanical nightmares with counter-rotating propellers doomed the project before it could prove itself. Now this is the Horten Ho 229, Nazi Germany's jet-powered ghost. Designed by the Horten brothers in the dying days of World War II, this revolutionary flying wing combined a radical shape with charcoal-mixed plywood designed to absorb radar waves. Its sleek profile and innovative materials made it history's first true stealth aircraft. The single prototype captured by American forces became the blueprint for decades of stealth research. Had the war lasted longer, this jet-powered predator could have terrorized Allied bombers with near invisibility. Next, the Northrop YB-49. The jet-powered evolution of the YB-35. 8 turbojets replaced the troublesome propellers, creating a sleek bomber that could outrun most fighters. Political battles and a catastrophic crash killed the program, but its DNA lived on. The Lockheed U-2. Not a stealth aircraft by design, but a stealth aircraft by altitude. Flying above 70,000 feet, it simply flew too high for most radars to effectively track. When a Soviet missile finally shot one down in 1960, the age of altitude stealth died with it. Let's move on to the Cold War development era. The Lockheed D-21 drone. A ramjet-powered reconnaissance drone launched from the back of a modified Blackbird. Its small size and high speed made it difficult to detect, though the program ended after several operational failures over China. Now this is Lockheed's HAB Blue, the aircraft that changed everything. Built under the codename Project Harvey, these two angular demonstrators proved that flat, faceted surfaces could scatter radar energy away from the source. Looking like someone had built an airplane out of broken mirrors, HAB Blue flew in complete secrecy from 1977 to 1979. Its revolutionary design confirmed that stealth was not just possible but practical. Every mission validated the radical mathematics behind radar cross-section reduction, paving the way for operational stealth fighters. Next up, the Northrop Tacit Blue. Nicknamed the whale for its bizarre rounded shape, this demonstrator proved that curved surfaces could also achieve stealth. Flying from 1982 to 1985, it tested low probability of intercept radar systems while staying invisible to enemy sensors. Its ungainly appearance hid breakthrough technology that influenced the B-2 bomber. The Teledyne Ryan Model 154 Compass Cope. A high-altitude stealth reconnaissance drone designed to replace the U-2. Budget overruns and technical complexity killed the program before it could reach operational status, but its design influenced future unmanned stealth platforms. Now this is the Lockheed F-117 Nighthawk, the world's first operational stealth fighter. With its angular faceted design and radar-absorbent coating, the Nighthawk could penetrate the most heavily defended airspace undetected. Flying exclusively at night during its early years, it earned the nickname the Black Jet. The F-117 revolutionized modern warfare during Operation Desert Storm in 1991, striking high-value targets with impunity while Iraqi radar screens remained blank. Though retired in 2008, occasional sightings suggest some remain active for classified testing missions. Continuing with the operational dominance era, the Boeing Bird of Prey. This single-engine demonstrator looked like something from a science fiction movie. Built using virtual reality design tools and advanced composites, it tested stealth shaping and low-cost manufacturing techniques from 1996 to 1999. Up next, the Lockheed Martin/Boeing Darkstar RQ-3. A high-altitude stealth reconnaissance drone designed for deep penetration missions. Its disc-like fuselage and distinctive shape promised revolutionary ISR capabilities, but escalating costs and performance issues grounded the program after just 5 flights. Then the Lockheed Martin X-35. The prototype that would become the F-35 Lightning II. 3 versions competed in the Joint Strike Fighter competition, demonstrating conventional takeoff, carrier landing, and revolutionary short takeoff vertical landing capabilities. Its stealth shaping balanced low observability with aerodynamic performance. Next, the Boeing X-32. The F-35's quirky competitor, featuring a direct-lift STOVL system and a distinctive chin intake that made it look perpetually surprised. Despite innovative engineering, its unconventional appearance and performance limitations cost it the largest fighter contract in history. Now this is the Northrop Grumman B-2 Spirit, the ultimate flying wing. Costing over $2 billion per aircraft, the B-2 combined revolutionary stealth with intercontinental range and nuclear strike capability. Its seamlessly blended surfaces, flush-mounted engines, and radar-absorbent skin make it nearly invisible to enemy defenses. Capable of delivering both conventional and nuclear weapons anywhere on Earth, the B-2 remains the most survivable bomber ever built. Only 21 were constructed, each representing the absolute pinnacle of Cold War stealth technology. Continue watching to see the fifth-generation stealth fighters dominating today's skies. Next up, the Northrop Grumman RQ-170 Sentinel. Nicknamed the Beast of Kandahar after being spotted at an Afghan airbase, this classified surveillance drone features a blended flying wing design. Its exact capabilities remain secret, though one famously crashed in Iran in 2011, revealing its existence to the world. Now this is the Lockheed Martin F-22 Raptor, the world's first fifth-generation fighter. Combining stealth, supercruise, advanced avionics, and thrust vectoring, the Raptor represents air dominance perfected. Its radar cross-section resembles a marble, making it virtually invisible until weapons release. Capable of cruising at supersonic speeds without afterburners, the F-22 can engage multiple targets before enemies even know it's there. Though production ended at just 187 aircraft due to extreme costs, the Raptor remains the deadliest air superiority fighter ever created. Then the Northrop Grumman X-47B. This tailless carrier-based stealth drone made history by autonomously landing on an aircraft carrier. Demonstrating that unmanned stealth aircraft could operate from the Navy's most challenging environment, it proved the concept for future carrier-based strike UAVs. Next, the BAE Systems Tyrannis. Named after the Celtic god of thunder, this British stealth drone demonstrator featured a sleek flying wing design. Built to test autonomous strike capabilities, it validated European stealth technology and influenced the Tempest program. The Dassault Neuron. Europe's collaborative stealth UCAV demonstrator, involving France, Italy, Spain, Sweden, Greece, and Switzerland. Its distinctive design tested advanced autonomy, sensor fusion, and low observable shaping for future European combat drones. Up next, the Sukhoi S-70 Okhotnik B, Russia's heavy stealth UCAV, designed as a loyal wingman for the Su-57. Its flat, wide fuselage and serpentine engine intake suggest serious attention to radar cross-section reduction, though true stealth capability remains questionable. The Lockheed Martin RQ-180. A rumored high-altitude stealth ISR platform, allegedly flying classified missions for years. Reported sightings describe a large flying wing optimized for persistent surveillance deep inside contested airspace. Its existence remains officially unacknowledged. Up next, the fifth-generation and international programs era. Now this is the Lockheed Martin F-35 Lightning II, the most produced fifth-generation fighter in history. Available in 3 variants, conventional A model, carrier-capable C model, and short takeoff vertical landing B model, the F-35 brings stealth to air forces worldwide. While less stealthy and agile than the F-22, its advanced sensors, networking capabilities, and multi-role flexibility make it the backbone of Western air power. Over 1,000 have been built for the US and allied nations, making stealth technology truly global. Then the Chengdu J-20 Mighty Dragon, China's entry into the stealth era. With its distinctive canard delta configuration and long fuselage optimized for long-range interception, the J-20 represents China's technological leap forward. Though its stealth characteristics and engine performance lag behind American fifth-generation fighters, hundreds are now operational, making China the second nation to field stealth fighters in significant numbers. The J-20 signals that American stealth dominance is no longer unchallenged. Next, the Shenyang FC-31 Gerfalcon. China's medium-weight stealth fighter, clearly influenced by the F-35's design. Built for the export market and potentially for carrier operations, it represents China's ambition to sell stealth technology internationally. Its development has been slower than the J-20, but recent progress suggests imminent production. The Sukhoi Su-57 Felon. Russia's troubled fifth-generation fighter program. While featuring advanced aerodynamics and weapons systems, its stealth characteristics are questionable. Exposed engine fans, gaps in panel fit, and protruding sensors suggest it prioritizes maneuverability over low observability. Production numbers remain minimal. Up next, the Mitsubishi X2 Shinshin. Japan's stealth technology demonstrator, testing advanced composite materials and radar-absorbent structures. Though small and limited in scope, it demonstrated Japan's capability to independently develop stealth technology. The program provided critical data for Japan's future fighter development. Next, the KI-KF-21 Borame. South Korea's indigenous fighter, featuring semi-stealth design with some external weapons carriage. While not a pure fifth-generation fighter, it represents South Korea's growing aerospace capabilities and reduces dependence on foreign suppliers. Then the TI-TFX Khan. Turkey's ambitious fifth-generation fighter program. Following Turkey's ejection from the F-35 program, the Khan aims for operational capability by the 2030s. Its design suggests significant stealth considerations, though actual performance remains unproven. The Boeing X-45 series. These experimental UCAVs demonstrated autonomous strike operations and coordinated multi-aircraft missions. Their kite-like shapes tested affordable stealth for expendable combat drones, influencing loyal wingman concepts. Next up, the General Atomics Avenger. A jet-powered evolution of the Predator and Reaper drones, featuring internal weapons bays and stealthy shaping. Its design balances persistence with low observability for penetrating contested airspace. The Kratos XQ-58 Valkyrie. A low-cost expendable stealth drone designed as a loyal wingman for manned fighters. Its modular construction and affordable price point suggest a future where stealth aircraft are numerous enough to accept combat losses. And our last category is the modern and next-generation era. The Shenyang J-35. China's carrier-capable stealth fighter, clearly influenced by the F-35's design. Recently photographed aboard Chinese carriers, it will give China's Navy stealth strike capability, fundamentally changing Pacific power dynamics. Up next, the FCAS or Future Combat Air System. A collaborative sixth-generation program between France, Germany, and Spain. Designed to replace the Rafale and Eurofighter Typhoon, it promises AI integration, optional manning, and loyal wingman coordination. Then the BAE Systems Tempest. Britain's sixth-generation fighter program, developed with Italy, Sweden, and Japan. Featuring virtual cockpit technology, hypersonic weapons capability, and swarming drone control, it represents the future of European air power. The Boeing MQ-28 Ghost Bat. Australia's loyal wingman developed in partnership with the Royal Australian Air Force. Its modular nose allows mission-specific sensor packages, while its affordable design enables risk-accepting missions alongside manned fighters. Next, the General Atomics NQ Next. The next generation of stealth ISR platforms, designed for high-end contested environments. Its advanced sensors and low observability promise persistent surveillance even against sophisticated air defenses. The Lockheed Martin State Route 72. A rumored hypersonic reconnaissance platform capable of speeds exceeding Mach 6. If operational, it would represent the ultimate evolution of the Blackbird legacy, combining speed and stealth for unstoppable reconnaissance missions. Up next, NGAD or Next Generation Air Dominance. The U.S. Air Force's classified sixth-generation fighter program. Recent statements suggest it features revolutionary propulsion, AI integration, and family of systems architecture coordinating manned and unmanned platforms. Its exact capabilities remain classified. Now, this is the Northrop Grumman B-21 Raider, the world's first sixth-generation bomber. Building on the B-2's flying wing heritage, the Raider incorporates open architecture systems, advanced materials, and artificial intelligence integration. Designed from the start for upgradability, it will remain effective for decades as new technologies emerge. Its advanced stealth coatings and optimized shaping make it even less detectable than its predecessor. With at least 100 planned, the B-21 will form the backbone of American strategic bombing for the next 50 years, ensuring air superiority deep into the 21st century.